Now I can make these things into percentage format. I know it doesn't make difference, but we're going to calculate something called geometric average return. For that, I need these things to be in what you want to call um, decimal format. I mean, I can show as percent, but underneath, it's actually decimal. Now I'm gonna copy these into this sheet. Let's put them here. Values. Well, I'm gonna make them have a little light background. Are these daily? In fact, they are daily. Yeah, yeah, yeah. I think so. Yeah, they are daily. Okay, that's even better for some of the stuff I want to do. I don't like it in that form, so I'm gonna call that date value or date. Left this for, that's the year. Middle of this, starting at the fifth, two characters, and right this too. Okay. Then I'm gonna copy these and paste the values here. Oops, not formats. And make these things properly date formatted. And get rid of these things. So these are daily returns to portfolios of these sectors, okay? They're evaluated since July 1st, 1926. So that's a lot of data. And let me shift these things down a little bit. Insert, shift cells down. No, I don't want to make those. So let's first calculate arithmetic average, not arithmetic, arithmetic percent, 1, 2, 3. Do you guys know the function for the arithmetic average? No, it's simple, average. Just select the range. What did I do? Oh, there's no K there. Since these are daily terms, those don't mean much to me. How about we make these things APRs? Okay. Actually, I may even have to do a correction, but I'm not going to worry about that now. I'll show how to make it. So I'm going to multiply these things by 365. So over almost 100-year period, looks like the best sector was high tech. Surprise, surprise. And then consumer goods. No, the best sector was health. I'm sorry. Then high tech, then consumer goods, then manufacturing, then other. Right? You guys probably were thinking, why was he hesitating to do the APR is at 365? Technically speaking, these holding periods are not equal. Sometimes they're 1 day, sometimes they're 3 days, sometimes they're 4 days, right? So you need to make a correction for that. I'm not going to, but we could have. Maybe I'll do it on the side before the last class, and I'll give that to you guys as it is. Now, I also want to calculate something called geometric return. Now, arithmetic average, here's the interpretation of arithmetic average. There is what? Over 25,000 days here, okay? If I randomly picked one of these days, what is the expected return that I get? So if I randomly picked day, recorded that day, and repeated this experiment infinitely many times, what would have been the average of those returns? That's what arithmetic average is. If, on the other hand, you're interested in, if I put in $1 in July 1st, 1926, and hold these until December 31st, 2024, okay, what would have happened to my money? Then convert that return into a daily return. That's what geometric return means. So let's actually do that experiment just for one of them. So let's do this for just consumer. Well, the first day it's going to be 1 plus that return, right? So I invested $1. Next day, previous day's amount times 1 plus that day's return. Of course, let's make the formatting proper. I made way too much money. Turns out in 96 years, uh, almost 96 years, actually 98 years, my $1 would have grown into 32,000 and then some, which is normal. But I need to convert that into uh, daily return. So geometric average would be that last number, okay, raised to the power 1 plus not 1 plus, I'm sorry, 1 over count of those numbers minus 1. That's the geometric average return daily, of course. So let me actually move this here, copy, and I'm going to use a different color for that. I do know other colors. I just don't use them much. And if I wanted to convert that to APR,